In this lesson, we're going to be adding and subtracting polynomials. Here's our first example of a polynomial. Polynomials are made up of terms. The terms are separated by addition and subtraction signs. So we have four terms in this polynomial. 4x squared is a term, negative 3x is a term, 2y is a term, and negative 8 is a term. None of these terms are like terms. Recall that like terms must have the same variable as well as the same coefficient. 4x squared, negative 3x, and the 2y are referred to as variable terms. The negative 8 is considered a constant term. The numbers located in front of the variables are considered coefficients. So in this example, 4 is a coefficient, negative 3 is a coefficient, 2 is a coefficient, and negative 8 is also a coefficient. On this slide, we have some examples of polynomials. On the first line, we're giving three different examples of polynomials. Each of those polynomials is only one term. If a polynomial only has one term, we refer to it as a monomial. So in this example, 7x is a monomial, 3x squared, y to the fifth z is a monomial, and negative 923q to the 15th is also a monomial. On the second line are two examples of binomials. A binomial has two terms. On the third line, we are given a polynomial that has three terms, and we can call that a trinomial. Notice in this example, we could say that this trinomial is written in descending order. To write a polynomial in descending order, we look at the exponents that are on the variable. Notice x has the highest exponent on it, 2, followed by 7x to the first power, and then there's no variable with the 4. So we could say that this trinomial is in descending order, and we could call it a second degree trinomial, and we would say that the leading coefficient is the negative 2. So here's our first example of adding two polynomials together. Notice we can just go ahead and remove the parentheses. And then what we're going to do is we're going to look for like terms. So terms with the same variable and the same exponent. We're going to rearrange the order of the terms so that like terms are side by side. So notice the x squared is next to the 2x squared, the negative 6x is next to the 4x, and then the two constant terms are together. And now we will go ahead and combine those. 2x squared and positive x squared, remember we can think of there as being a 1 there, adds up to 3x squared. 4x and negative 6x is equal to negative 2x. And negative 3 and negative 2 is equal to negative 5. So we're left with a second degree trinomial, and notice the leading coefficient is 3. Now, this example is different because in this example, we are subtracting one polynomial from another. So what we need to do first is look at the minus sign that's in front of the parentheses. We need to think of that as being a negative 1 in front of those parentheses. And then we're going to have to distribute that negative 1 to each of the terms in that polynomial. So notice when we distribute the negative 1 times 2y squared is negative 2y squared. Negative 1 times 6y is negative 6y. And negative 1 times negative 1 is positive 1. Now we can rearrange the terms so that like terms are side by side. And then we will go ahead and combine like terms. 3y squared and negative 2y squared is equal to 1y squared, but we don't need to put the 1 in front of the y squared. Negative 5y and negative 6y is equal to negative 11y, and 7 plus 1 is 8. So we have a second degree trinomial with a leading coefficient 1. In our third example, notice the first two polynomials are being added together, but then we need to subtract the third one. So once again, we need to think of a negative 1 as being in front of that third polynomial, and we need to distribute the negative 1 to each of those terms. Negative 1 times negative 8 is 8p squared. Negative 1 times negative 1p is positive 1p, and negative 1 times 3 is negative 3. Now we can rearrange the terms so that like terms are side by side. Then we can go ahead and combine like terms. 4p squared plus 8p squared is 12p squared. Now notice we have a 1p and a 2p which add up to 3p. But then if we subtract 3p, we end up with 0. Negative 3 and negative 2 is negative 5. Added to 1 leaves us with negative 4. So our final answer is a binomial, a second degree binomial, 12p squared minus 4. Our leading coefficient in this example is 12. Another way that you can simplify these, instead of rearranging the order of the terms, is lining it up vertically. So you could write negative 2x squared, positive 3x, and negative 5, and then write the negative 4x squared below the negative 2x squared, the positive x below the 3x, and the positive 3 beneath the negative 5. So I've just lined up the like terms. If you'd like to put a 1 in front of the x, if that helps you, go ahead. Negative 2x squared and negative 4x squared is negative 6x squared. 3x and 1x is a positive 4x. And negative 5 and positive 3 is negative 2. We have a second degree trinomial with a leading coefficient of negative 6. Remember, in this example, we need to put a negative 1 in front of the second polynomial and distribute it. First, I'm going to go ahead and drop down the 5x squared, the negative 9x, and the positive 5. And now I'll go ahead and distribute that negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 6x is negative 6x. And negative 1 times negative 1 is positive 1. Combining like terms, 5x squared and negative 2x squared is equal to 3x squared. Negative 9x and negative 6x is equal to negative 15x. And plus 5 and plus 1 is equal to plus 6. So we end up with 3x squared minus 15x plus 6. This is a second degree trinomial with a leading coefficient of 3. In our final example, notice it's the middle polynomial that's being subtracted. So that's where we will have to change our signs. I'm going to put my negative 1 in front of that. Now first I'm just going to go ahead and write my 5x squared, my negative 9x, and my positive 5. And now I'll distribute my negative 1. Negative 1 times 6x squared is negative 6x squared. Negative 1 times negative 1x is positive 1x. Negative 1 times 4 is negative 4. Now the third polynomial is just being added, so we don't need to change our signs in there. So I'm just going to drop that down. I'm going to put the 2x squared here, the positive 6x, and then the negative 1. And now I'll combine like terms. 5x squared and 2x squared is 7x squared, minus the 6x squared gives us 1x squared. I don't need to put the 1 in front of the x squared. 6 and 1 is 7x, and then if we add the negative 9x to that, we get negative 2x. Negative 4 and negative 1 is negative 5. If we add 5, we get 0. So we don't have to put anything there. So our answer is x squared minus 2x. This is an example of a second degree binomial with a leading coefficient of 1.